Okay, so I've decided it's time to power this up. I've put the output transformer on and I've put a choke in place of the speaker. It's only about 6 Henrys, but it'll do just to test this out. Put all the valves back in, which I haven't identified properly yet, but I'll get there. Connected up via the bulb, variac and the safety isolation transformer. So this on-off switch isn't fantastic, the contacts appear to be corroded, so I'm going to bring it up and switch it on with about 20% power. Bit of luck, some of these lamps will illuminate to let us know we've got low tension, and I've got the meter connected up to the high tension so I can see it. Unfortunately it's out of shot at the moment, but right, I'm going to turn up to 20% and try flicking the switch to see if anything happens. Nope, nothing visible happening at the moment. It's always the same problem with the power meter because that's on the variac as well, so I can't even see if I'm drawing any power. It might be worthwhile seeing if there's a meter on the low tension side perhaps, but I'm not sure which one's medium wave, but I'll try a little bit more power. 30%. Ah, yes, there's a slight lamp illumination. Yeah, that's lighting, that's lighting. That one isn't. Maybe the... yes, I have cleaned the contacts, but maybe not well enough. There we go, is it going to come on? Yeah, it's just a fractioner's glow there. Okay, nothing happening on the HT at the moment. I'll leave it on the middle one. Okay, bring it up to 40. Can I see any glow on the valves? No, I can't. Okay, I've got variac on 70%. I've only got an HT of 109 volts. It just seems low. The diagram for the A48, I know this isn't an A48, but that's suggesting a cathode voltage of 300 volts. So that seems exceedingly low. I'm looking at the smoothing capacitor. Anyway, we've obviously got audio action, so that's good. If no radio action. No radio action at all, no noise, nothing. It could be the oscillator's not running, perhaps the voltage isn't high enough. Because this HT is looking a bit low, I'm a little concerned about going higher, but I'm going to push higher anyway. 75%. Oop! What was that? Ooh! Ooh! Don't like the sound of that. Right, and the bulb's come on, so I'm going to turn down and see what that was. Something definitely was flashing over there. I'm just been looking with the meter to see what's happening, because obviously there was that loud crack, and now I've got no HT if I bring it up gradually, although I can see AC on each side of the rectifier. But I've just spotted this cable is very close to the connection there. I wonder if it is actually shorted, so let's find out. Because I was wondering if it was this cable here. It looks awfully close. No. Okay, if I just zoom out so we can see the meter. Yeah, I think you can see it now. Let's just have a look. Just see. Yeah, 200 ohms. 200 ohms. HT. Ooh. There's 180 ohms across the HT. Now that's not good. So something on the HT side has broken down. So just looking at the circuit diagram, so you've got this is the cathode of the rectifier, and it's about 160 ohms there. Then it returns back from the choke to the second smoothing capacitor, and that is a complete short circuit. So some points here on the chassis, one goes to the tone control here, another one disappears to the IF here, so presumably I can take a few wires off here to see if I can trace where it is. Things still in circuit that could cause a dead short circuit. Output transformer, but that's doesn't look like that's the cause. The screen of the output valve, the anode circuit of the IF valve and the screen of the IF valve, and the mixer circuits etc. are VAR resistors to their relevant screens and anodes. So I think it's probably a wiring that went fun, and because we had the chassis round this way we couldn't see what was happening, but I'm going to pull some of these connections off and we'll see if we can find out where the short circuit is specifically. But that was a fair old crack at the back of the set, so something failed rather suddenly. Okay, I can see that removing this one cures the problem, but if we look really carefully I think I can see where the problem is. Here, the voltage goes up to the bit of board on the IF can, but if we follow here to there, yeah, this wire here I've accidentally bent it and it's touching this connection which goes to the chassis, so that'll be what that was. Whoops. So short is removed now, hopefully. I can see the HT's come back up to 2.7 volts, so I'm going to go straight to 50% and bring it back up again. And I'm still curious why the HT was so low. Okay, it could be the rectifier valve is a bit weak, but I'm considering putting a meter in and measuring current now. So I can see if there's a excessive current being drawn. Okay, HT's coming back up now. We'll let that come back up. Hopefully no loud cracks this time. Oh yeah, that's coming up. Right, we'll leave that to come up again. Right, so I've got 170 volts going into the set now, and it's drawing about 27 watts. I'm not really hearing any radio action. There is a click as I switch wavebands. No, there's no radio action there at all. Okay. Just wiggle the RF valves. No, nothing there at all. So amplifier's working. That's good. There's no radio action at all. Okay, perhaps try some IF injection next. Okay, I've just clipped the IF rather haphazardly on the grid lead to the IF valve. I got modulation on at 465 kHz, so I'm now going to try not to block the camera and just creep it up a bit. Oh, there we go. That's neg 17, and we have some action. Because I don't know how much coupling exactly I've got on there, it's a bit difficult to say. It's just a crocodile clip round the insulation. But at least I've got some IF action, so that's something. I'm going to have to work out which waveband is which with this. Interesting. At the moment I'm not quite sure which position is which band, so that's a bit silly. I haven't got the glass out for me to see. I should have made a note of this before I put the glass away. But anyway, at least we can hear some IF action, so something must be working. I've thrown the little transistor radio on top just to see if I can hear any local oscillator action. Doesn't seem to be, does there? So no, nothing at all. Of course, another thing I forgot to try is finger on grid valve. Sorry, grid valve on the RF mixer valve. Yeah. Nice cacophony of noise there. I think we can even hear a radio station. So it's got to be the oscillator, hasn't it, that isn't oscillating. So that seems to be the issue. A friend of mine is round at the moment and just happened to have a look at the chassis while I was out the room. And can you see the detached connection? Yeah, that's off this coil here, which I believe is the oscillator coil, so that's got to be soldered back to the chassis. That might be something to do with the fact the oscillator is not working. I'm not even sure what the component is. It's in a sleeve, but let's solder that back and see what happens. Right, and bring it back up and see what happens. Right. HT coming up. Ooh, yes. Sounding a bit more promising now, isn't it? A bit quiet at the bottom. But, ooh, nice bit of modulation hum. Shortwave. Ooh, that's alive. Long wave. Not sounding so promising, but ooh, there's something there. I'd expect to get radio 4, but I have cleaned the contacts, but they were very dirty. Yeah. Okay, well, something's happening anyway, so that's good news. So that's obviously what it was. That's why the oscillator wasn't working. So, just made this dampening device. It's called for in the manual, 100 nanofarad and 20k. It's a bit awkward on the circuit diagrams. They don't seem to use the pin numbers, they use test points. I have the A48 manual, but the valves and the valve holders are in a different place, but I should be able to work out the numbers by rotating it and turning it round the other way. I think I should be able to work out where to clip this, but I think I'll sit and do a diagram just so when I do it for real I get the correct points to attach this. I'm going to need the scale on soon to do the alignment, and I'm just working out at the moment how to put the scale back on. There was some rubber parts that have disintegrated which are fixed along here, just where the edge of the tuning scale is. The only idea I've come up with is to cut up some, I haven't got any thin rubber like that, but a piece of drive belt, so I've got many rubber drive belts, so that's what I'm going to use to make sure the glass has got something soft to sit on. It'd be a shame if I broke the glass scale at this stage. Just trying the scale in position. I think it goes approximately here. It seems to be sitting on the rubber nicely. These brackets, there's another 2 to go on here. They're obviously going to need some sort of rubber underneath, or felt or something, but just gently remove the scale. see it's coloured. So each wave band lights up a different colour. Just see that in the light. There we go. I'm just setting up to do the IF trim. It seems to be working from the front to seems to be working from the final IF backwards. See, the dampening unit is in. I've got the output from the signal generator going to the grid, the top cap of the IF valve. So I've got 465 kilohertz, 465 kilohertz ready to feed in. So I'll see what happens. It's suggesting tuning to the top part of the long wave band. I assume that means with the capacitor fully out, so that would be the top end, I'm assuming. And then I'm going to adjust C31, which according to my drawing is the can there. The damper definitely does something. As we can see, it certainly reduces the output to the unit. So I'm just going to find C31 now. I've got the I'm going to see if I can turn the output down just a little bit more. That's barely audible. Amplitude compensate 1 dB. Right. That's better. Oh, I don't think I want to go much lower than that. Right, where is C31? C31 is there. Good grief. Well, that's C31 done. Okay, so now I move the dampening unit to anode of V2, which is that point there I've marked. No change of input, so and then I'm going to adjust C34. It's going to be the primary of the second IF can. Wait for it to warm back up again. Okay. Now I adjust C34 so I can back it off a bit more. I must confess the output's quite high, I thought. Okay, it's now C34. There it is. Right, that's that one done. Being very careful here because this is obviously live. Well, now I'm applying the input signal into the first valve, the mixer oscillator. It said artificial aerial. Well, I obviously didn't read something. I'm just using a 4K7 resistor. I'm sure that will be fine. It says switch it to medium wave, which I've done. So now the next trimmer. By the way, the dampener is on the grid of the IF valve now. It certainly does dampen it down, and it's telling me to Right, switch to medium wave, done that. And it's going to be C24 now. So I'll just refer to my drawing. Where are you? The last thing I want to do is get the wrong one. I have to start this exercise again. Although it's suggesting that I might have to do it twice if the readings were a long way out. It's quite a lot of turning I've done here. Good grief. Okay. Unlike last time, I didn't have to move anything signal wise, just a dampener, so now I'm going to have to move the dampener again, so I'll switch off and move that now. Okay, so the dampener is now on the anode of the valve 1, the mixer oscillator. I'm going to adjust C28 very carefully. Here we go. Right, well, we've seen big gains in the output, haven't we, on most of these, so that is good news, but I suspect, as it says in here, if it was only a small adjustment, if a large adjustment, it is advisable to repeat the whole procedure. Okay, no problem, I'm going to do that off camera because it's a lot easier. I must confess that talking and doing this at the same time is quite difficult on camera, especially as I don't particularly want to contact any live parts. I've got my scale on now. I think it's in the right place. There's too much light in here really to see the scale lit very well, but I am still running through a light bulb, so it's probably a little dimmer than it should be, but long wave's a little bit more lively at the moment because I had a quick look and the oscillator trimmer was completely unscrewed, which doesn't really sound like a particularly accurate point. I noticed that Droid for each Radio 4 comes in at the right point, so that was a fairly good guess, but I'll now go through a proper alignment. Twigging the IF seems to have certainly livened the radio up a lot better, though I notice its audio output seems to be a little bit limited. That could simply be the speaker I've got connected up to the output transformer. But right, we'll have a look at the procedure next. It sounds like we're going to start with shortwave, so let's get the signal generator on. Well, I've converted the meters from the manual into kilohertz and megahertz, so we know where we're going. The calibration point is 21 meters, which is 1428 megs. It says to pick the second point. When screwing in. First one. Well, I don't seem to be finding a second one. First one. Well, that's kind of interesting. Unfortunately, we're picking up a load of interference from something in here, but I'm not sure what. Well, that's kind of interesting. I'm only finding one point with such a low. which is such a low IF, I wouldn't have thought it would. I think this screwdriver is affecting it. I'm going to have to switch to something plastic, I think. Probably about the best I'm going to get this. Yeah, I wish I knew where that switch mode noise was coming from. It's quite annoying actually. No, it's not that light. Must be something on the bench. I'm not entirely sure where it's coming from. Well, that's a lot better. Actually coming from the oscilloscope. Digital oscilloscope. Yeah, that's still pretty loud. Okay, next point is, let's have a look, C7. So that's the trimmer. I might get away with a metal screwdriver on that one. Good grief, that is stiff. Have I got the meter in? Let's just move the camera, that's better. Right. That's going up. And now down. Ooh, come on. It isn't helping with the fact that I suspect the oscillator is, yeah, that's affecting it as well. I don't know if I've got any larger plastic adjusters. Let's have a look. Just found a nice plastic trimmer. Oh my goodness, this is not easy to turn. Oh. Very, very difficult. Oh, well, that's buggered my plastic trimmer up. Oh, there we go. Let's try the metal end. Oh, it's wanting to be screwed up tighter rather than looser. This is very difficult. Well, that's definitely the wrong way. Let's try again. There we go. Back a bit. Yeah, about there. I think that's about the best. What's a pity I've broken that. Might better resharpen it. Okay, what's it say here? But cash should be taken to high capacity adjustment station, 20 metres. Right. Check the 16 metre still registers correctly. That's 18.75 megs. Okay, 18.75 megs. And then tune down to 16 metres. No, not so good. Nope, nothing on 16 megs. That's right at the end of the scale. We have a possibility of the veins are right out. Oh well, that's not so good. I'm not too worried, so I won't worry any further about that. Let's see what the next band is. That'll be medium wave. Okay, so medium wave. 220, which is 1.36 meg. 1.36 megs. Switch to medium wave and tune to 220. Oh yes, that's not too far out. So where is the oscillator coil for that one? That is right, just C17, which is this one here. C17 trimmed. Ah yes, because it's got a grid trimmer and an aerial trimmer. If you remember, we were talking about this having two tuned circuits on long and medium wave to increase the Q, it seemed. So which one, in which order? C2 in that order. So C2 is where? Here. 40, oh, that's coming up a bit. That's coming up a lot. Good grief. Mind you, if we found the long wave one was unscrewed, then it's possibly somebody has been playing with this one as well. So that's that one, and then there's the one on the capacitor, which is C6. I wonder if they interact. I bet they do. Good grief, I am struggling to move this again. That is really stiff. Gonna have to use this one. Same problem again, I can't seem to screw the trimmer up enough. I wonder if with time these spaces expand or something. But, that's certainly a lot better. This is not ideal. I was hoping to find a peak and then find the other side of the peak, but it's a bit concerning when it's like that. I noticed the trimming on this, that we're not trimming in 2 points, we're only trimming in 1 point, which makes you wonder whether it's going to be insensitive at the lower end, but I suppose we could check that. If we try somewhere at the bottom end of the band and see what the calibration's like. So, I'm just... Nope, definitely. I did notice that the medium wave seemed very, very low sensitivity at the bottom end. I could hear the noise dropping off. I'm at 500 meters, which is 600 kilohertz, and the meter's only reading 6.7, whereas it was reading 120 before. So that's showing quite a loss of sensitivity at that frequency end. That's a bit concerning. There's no way to trim the aerial coil, sorry, not the aerial coil, I beg your pardon, the oscillator coil, for any error. It's saying for what, 520 meters, so there is an error. Perhaps I'll try it at another point and see what sensitivity is there. We're now at 120, we're now at 120 almost again, same level, and I'm tuned at 800 kilohertz, so there seems to be a really big misalignment going on when I come down below 800 kilohertz, because that's fine. That seems to tie into what I was hearing, so I'm just trying to wonder why this is misaligning so much when I'm on the lower part of the scale. It's a bit puzzling. Okay, here we are at 700 kilohertz and 65 on the meter, so it's about half. So that's 3 dB down there, but it seems to be below 700 kilohertz it absolutely bombs for some reason. It's like it's completely mistracking. So we're obviously adding too much capacitance at the bottom, or appear to, and then possibly not enough at the top. We've got a 3-ganged capacitor with all the same size vanes. This is unfortunate. We've added a lot of capacitance at the top. I'm just seeing on the medium wave, there are no fixed capacitors, only the variable capacitors. It's unfortunate. Why is the tracking so bad? Okay, so just a reminder to myself, this is the grid trimmer C2 on the medium wave aerial coil, and then of course you've got the second tuned circuit here, so it would be C6 I'm altering here to get a resonance there. So the question is, which tuned circuit isn't tracking, or in fact both of them not tracking, and what can I do about it? That's a good question. Okay, you just hear it there, I'm just substituting each gang on the front end tuned circuit with an external capacitor, and I'm just going to measure the capacitance and just see if I can just see in my mind what's going on here. A bit of a pain in the neck to do this because I had to take the grid wire off the capacitor, so now you've got extra wire picking up noise, but that's nice and high. It's peaking quite well. This is the grid tuning, not the separate tuned circuit. I'm not sure what that crackling is. Okay, so going from the last clip, I've just taken this capacitor out and put the second gang back straight on. I can barely hear the tone now, whereas we had it peaked quite nicely. So there's definitely a tracking issue going on here. Question is the setup procedure wrong? Well, it can't be, because that's a Murphy manual. Surely that can't be wrong, the procedure. Have I done the procedure wrong? It's a good question. I don't know. Very concerning, that. So yeah, that's the grid. That's the grid tuning, the one that's most out, and that will be this circuit here. I think the Shortwave has a lot of effect because that's quite low capacitance, but all I've got is C2. Just made some notes of the capacitance I got. So on the C6 side, which is the auxiliary circuits, 492 versus 471 peak. On this one, which is the grid circuit, 481 puff on the original capacitor that's in there, and 448 gave me a peak using the external capacitor. So that one's showing more of a 32 picofarad difference. I don't think this has got quite so high Q, so I think this error here isn't quite so much of a problem. The question is, can I correct this by adjusting the oscillator in a different fashion, maybe, so the tracking is a little bit different at the bottom. We know I'm having to have it on 520 meters to get 500, so there's obviously an error at the bottom, so it might be worthwhile me setting the oscillator as a compromise, perhaps. That's going to reduce the sensitivity at the other end as well, but that might be the way around it. Or can I bend any of the plates on the capacitor? Okay, where am I? So it's obvious that there's some mistracking between the capacitors on this and the tuned circuits. Now it is possible to bend the plates, the outer plates on the capacitor. For some reason I'm not very keen on that, but what I've done as a compromise at the moment is we know that at 220 meters, 136 megs, that it was pretty accurately aligned. But we know at 600 kilohertz, 500 meters, the oscillator, I had to tune it to 520 meters to get 500 meters. So the oscillator is obviously out. So what I'd done as a compromise, I twigged the oscillator slightly so that it tunes in at 510, but now I've got a 10, slightly more than 10 error at the 220 meter error end. But I'm at 600 kilohertz now, and as you can see the meter reading is a lot higher. It's about 110 at the high end of the band, the 1.36 megahertz end. So it's an interesting compromise I've got, but it's whether I want to start bending capacitor plates to see if I can make it better, or whether I accept this is as good as it's going to be tracking wise. You know, I certainly could bend the plates, but that can end up taking hours and hours and hours. So it's whether I want to do that or not. Right, you can see I've got a higher reading now. What I've done is I've bent the plates in, I think, 3 parts. I've just bent the plate on the grid side, the grid tune circuit. I've bent it slightly away from the plate, and as you can see we've got an improvement in the signal. So it's obviously making the capacitance. We saw from the piece of paper we were looking at a little while ago that we actually needed less capacitance, so there we go, we have got an improvement now. Hopefully this is clear enough for you to see that you can see where I've bent the capacitor out there. You can see it's separated in distance, but anyway, just zoom out. These numbers here just represent what the meter says at various frequencies: 600 kilohertz 81, 700 120, 1000 157, and 1300 110. That's not bad. That's a lot better than where we were. I'm not sure I dare bend any more plates or compromise it anymore, but it's not too bad. It's much more even over the band now, and we're not dying as soon as we get to 600 kilohertz now. I don't think I receive any stations below 648, so I think that's going to be fine as it is. I've just got to tune up the long wave oscillator, and that should be it on the alignment. I'm just going to line up the long wave oscillator. If I can just make sure I alter the right one, which is this one. Goodness, that's stiff again. Oop. That looks pretty good. I have one station here that I would listen to, and of course that's Droitwich or Radio 4, so I'm sure it'll line up okay on that. Right, okay, I think that completes the alignment. To see if that's going to be okay, I'll try an aerial in it and give a swing round and see what I receive. Well, that seems pretty damn good. That's not bad considering how weak it is here, so that's not bad at all. Well, that's good. I can get 648. Unfortunately, it's just transmitting a blank carrier at the moment. I did hear a little snippet of music and then it disappeared, so I wonder how they feed that transmitter. There's certainly nothing there at the moment, but so that's good. That seems quite lively. Yep, that's not too bad. I'd say that's fairly standard for what I get with a 4-valve set. Well, 4-valve plus rectifier. So that's not too bad. I've got about 10 foot of wire connected to it at the moment, so yeah, that's quite good. Still not transmitting anything. Well, I think that's good. I think I'm going to live with it there. I need to paint this tuning. Oops. Break the glass. This will need painting, I think. What else do we need? I need to look at the loudspeaker next, I guess. Groan.